Okay, sorry about the break. So, are we all back? This network is. So, the three most common types of cache memory are described in figure 2, which we're going to see. Then the three most common types of cache memory are described in figure 2, which we're going to see. Then memory errors occur when the data is not stored correctly in the chips. The computer uses different methods to detect and correct data errors in memory. So different types of error checking methods are described in figure 4. So we're going to see this is a DIP. This is a SIM. This is a DIMM memory. Okay, all these things you see are called chips. Those black things there are called chips. Then this is a SODIMM. So let's look at each of them. A single inline memory module is a small circuit board that holds several memory chips. Okay, so a SIM have 30 pin or 72 pin configuration. All right, then we have the dual inline memory module, which is a circuit board that holds XDRAM. It holds SDRAM. Okay, it holds DDRAM. It holds DDRAM, SDRAM. It holds DDR2 SDRAM. It holds DDR3 SDRAM. It holds DDR4 SDRAM chips. So there are 168 pin SDRAM DIMMs, and there are also 184 pin DDRAM DIMMs. Okay, so you have 240 pin DDR2 and DDR3 DIMMs, and you still have 288 pin DDR4 DIMMs. Now, when you're buying your motherboard, from that question it asked, your motherboard has what they call a manual that tells you the kind of memory module that you have. So most motherboards memory modules come in a DIMM memory module because it's the latest technology. Okay, it comes in a DIMM memory module. So when you buy a system from the market, or you buy a motherboard from the market, it automatically comes, the latest board automatically comes with a DIMM memory. Now, if somehow you go to the market and somebody is trying to sell you a SIM, that means you're talking about old-fashioned system. You're talking about Pentiums, old-fashioned system. But when you're talking about the latest board, all right, the latest board comes with a DIMM memory. Okay, the latest board comes with a DIMM memory. So let's look at the small outline DIMM. So the small outline DIMM has a 72 pin and a 100 pin configuration for support of 32-bit transfers, or a 144 pin, 200 pin, 204 pin, and 260 pin configuration for support of 64-bit transfers. This smaller, more condensed version of DIMM provides random access data storage that is ideal for use in laptops. So you can use this in laptops, you can use it in some printers, some direct image printers use this particular memory, and other devices where conserving space is desirable. Okay, so a SODIMM, once you see this, you know it's for laptop. If it's not for your laptop, it's for a DI machine, which is a direct image machine, all those big machines that are computerized. So they use this particular memory. But if you're looking for the latest systems that you have in the market today, you look for a DIMM memory. Okay, so a DIMM memory always have chip in both sides. Okay, most of them always have chips in both sides. Okay, so let's look at the diagram. So now I want to talk about this part. Is something I needed to understand. This is the functions and process. Okay, L1 cache is an internal cache and is integrated into the CPU. So a CPU can have various modules, each with a different amount of L1 cache. Now, how does a cache work? A cache is like a small environment, all right? During your process, when your data are moving, and you find yourself in a position where maybe the system goes off or a particular file has been removed. So it's like a process, how will I put it? A bin, it's not like a bin. Let me not call it a bin, but it stores all data movements. Like every data movement, it enables all the smooth. It's like a police officer. You understand? That is controlling a particular space in the memory. So at a particular time, if your system goes off, you understand, and data stored in that place is not cleared, those data keeps accumulating, and the more it accumulates, the space you have in that cache will be smaller. And when you have a smaller space, your system will become slow. Okay, so as we're going through it, you get to understand more. So an L2 cache is an external cache and was originally mounted on the motherboard near the CPU. So an L2 cache is now integrated into the CPU. So most times they tell you when your system goes off, you understand? Or when you're even, okay, let's use your phone. So just the way you have your phone, you know, when you're using your phone, you find out somehow your phone is becoming slow. When you try to open a particular application, it becomes slow. Now, you'll be told to sometimes use a particular software that clears some unwanted files in your in the physical memory of your system. So you find out that, like my own phone, my own phone, you know, is actually an Android phone. Most times when I use the phone for so long, and I notice that it's becoming slow a bit, I download what they call something booster that goes to clear all the caches. It goes there and you can see all those files that you have opened. Many files you have opened, you know, there are even some files you've opened, you finish watching the movie, you close it, or you didn't close it well, or somehow you just left it. Those files will be piling up on that particular place, and you cannot see it until you clear it with those apps. So some phones, they call them booster, something booster can do the clearing and all that. So what I'm trying to say is, the way it is on the phone, that is what it is on your system, both laptops or desktop. There's a process of data movement, okay? So at a point where the memory, you know, remember that the files from your memories are volatile, from your, from your RAM can wipe up at any time. So now at the stage where the process is going on, let's say there's a movement of data, the light now goes off. Your memory goes back to your normal stage, but those particular data that has moved are going to be stored in the cache of the system. So what they are trying to explain to us that these caches are available, okay, in three ways. We have the L1, we have the L2, and we have the L3. Now, the L1 is an internal cache, and it is integrated into the CPU. A CPU can have various models, each with a different amount of L1 cache. So we now have the L2 cache. This one is an external cache and was originally mounted on the motherboard near the CPU. So an L2 cache is now integrated into the CPU. Now, don't forget what the CPU does. The CPU is the general overseer, is the one that moves, controls every process of data within your system, okay? Then we have the L3. The L3 cache is used on some high-end workstations and server CPUs. I don't know if I've been able to explain this better, but if you have any question with what I've said, please ask so I can explain much better. Any question? Any question? We want to move to the memory errors. Do you have any question, please? I don't understand. Please ask questions, please, before I move into the memory errors. So we just talked about the cache of the memory, or the cache on your system. Any question?
Go ahead, go ahead.
Okay, all right. Okay, so let me just put it in a way that you understand, okay? A cache is like a collections of items, okay? Which is data that is stored in hidden places. You cannot access it. You cannot see it, just the way you see normal data. But those things are stored there just because, you know, a particular process was in that. Okay, so it's like you're moving like this normal game the children plays, this normal puzzle game, like you're moving a moving train, and somehow something happens along the line. Now, for the memory, you will go and start all over again. For the memory, you have to go and start all over again. That's for the RAM memory. So the process of you going to start, those data cannot go. So the data have not arrived at their destination yet. And they have left where they are coming from. You understand what I'm trying to say? So for them to have a place to stay, because the light has already gone off. So the process has to end at that point. Those data are going to be stored in the cache. That is the work of the cache on the system. So let me move to the next. So we're going to talk about the memory errors now that we have. We have three types. We have the non-parity, we have the parity, and we have the ECC. Now, the non-parity memory does not check for errors in memory. Okay, non-parity RAM is the most common RAM used for home and business workstations. Okay, then we have parity memory. So the parity memory contains 8 bits for data and 1 bit for error checking. So the error checking bit is called a parity bit, okay? Then the ECC is the error correction code memory, which can detect multiple bit errors in memory and correct single bit errors in memory, okay? So on servers used for financial or data analytics, ECC memory modules may be required. So now, if you're using, like I mentioned to you, these are the errors you see on memories. Now, they are trying to explain the different types of errors. We have the non-parity errors, okay, which does not check for errors in memory. Non-parity RAM is just the most common RAM used for home and business workstations, okay? It doesn't check for errors. Then we have a parity memory, which contains 8 bits for data and 1 bit for error checking. All right, so the error checking bit is called a parity bit. Now, then we now have the one they call the ECC, which is the error correction code memory, which can detect multiple bits errors in memory and correct single bit errors in memory. It's always found on servers. So banks, big organizations actually use memories that has an ECC. Okay, so memory that have an ECCs are like most of the memories you use on server workstations. So what they're trying to say is the DDR3, the DDR2, many of them actually are ECC compatible memories. Okay, they are ECC compatible memories. Meaning, if I go to the market, a DDR or a DDR3 has an ECC. Okay, why the most times the SDRAM, which is the whole kind of the whole kind of system, is the one that you find that doesn't have, which are non-parity. Okay, Felix, please, can you mute your video? I don't know if I can do that from here. So, so we move to the next, please. If you have any question on this, please ask. Now, it's not like it's a topic where you have to focus on. It's just, you know, an idea that you should have as an IT person when you are doing a troubleshooting. Okay, these memory errors actually are used when you're doing troubleshooting of a system. Now, somebody calls you, the system is not working. You want to check why the system is not working, or the system is slow and all that. You should know, which we're going to get into that area, where a system is having a problem. You know the kind of issues it's having. You should know that, okay, this system is having this problem because the cache has not been cleared, or because, you know, the kind of memory it's using is having some parity issues. Okay, so that is just why they're mentioning these memory errors for you. So we move on if there's no question. So we're going to check if you really understand what we've just done. Okay, so we're going to do it the same way: Group A, Group B, and Group C. So let's check our understanding. As we all said, we understand. All right, so let's move on. Number 1, Group A. Which statement best describes an EPROM? Is it a type of RAM? Is it a type of volatile memory? Does the data can be erased using a strong... Hello? Can the data... Hello? Hello, can you hear me clearly? Group A. Group A.
Data can be erased using a strong ultraviolet light.
That's your final answer, right?
Final answer. Final answer.
Correct. Okay. Group B. A user complains that their computer is running very slow. A user complains that their computer is running very slow. What solution would help to speed it up? Group B. A user complains that their computer is running very slow. What solution would help to speed it up? Add more RAM, use error correction code memory, switch to L1 cache, erase and refresh the code in ROM, add more room. Group B, we are waiting.
Hello.
Hello, we are waiting for your answer.
Let me see. Is anybody there? Let me see.
Hello. We can hear you clearly. Shiva, do you want to answer the question?
I am not sure, but I will say add more RAM.
Add more RAM. That's your final answer?
Yeah.
All right.
I can.
Is that the final answer?
Yeah, I don't know.
Group B, help out if she's not sure what you're saying, but I'm going to select it if she should go ahead, if it's a final answer. Group B, your final answer, okay. Correct. I think I mentioned it. It's correct. All right. All right, Group C. Group C, which RAM from the list provides the fastest performance? Which RAM?
DDR4.
DDR4. Final answer?
Mr. Shola, this brings me to the question.
SRAM.
This is which RAM from the list provides the fastest performance? Fastest performance.
SRAM.
No, GDDR RAM.
Okay.
The R4.
SRAM.
He said it's SRAM. Final answer. Someone said it's
DDR4.
DDR4. SDRAM, right? So which is the answer? You guys will agree.
GDDR SDRAM. GDDR SDRAM. Yes, that one.
I don't think so. I don't think that is correct.
It's GDDR SDRAM.
Bro, are you sure?
Yes, final answer.
All right.
Yeah, I think it's okay.
Final answer, GDDR SDRAM.
Can we all see it?
Yeah, we can see it.
So, is it correct or wrong?
He's wrong. He's wrong. Group C, Group A bonus. Group A bonus.
So Group A bonus, can you go ahead and tell us the bonus, please?
Bro,
Yeah,
bro,
SRAM. SRAM.
Bro,
Group A, SRAM.
bro, you know that's what I was saying, no, bro.
Group A, SRAM. Group A is our bonus. It's gone.
When we were, when I
said-
moved, when I moved to,
I-
when we had the last, yes, GDDRAM is fast. DDR3 SD
Static RAM
RAM
is
is fast,
It's the fastest.
but
Static RAM.
the fastest, which was explained even when we moved to the next this
Yeah.
thing, was the static
It's the
RAM.
static RAM. Yes, SRAM. Yeah.
So please, let's take note of this. Very important.
Yeah, Group A chop the bonus.
Group A chop the bonus. All right.
Yes, please add it to
And I
our
was
map.
saying it. I was saying it's extra. Eh? That,
You were
that
saying
was
you,
very sure.
but you were not
You
sure.
weren't sure, man. You weren't sure.
He was
You
not
weren't
sure.
sure.
He
You weren't
wasn't
sure. Wasn't sure. So please, let's take note of that. Very important. So group, the next group is Group A, right? So Group A,
Group A, yes.
your
was our
question,
bonus.
please.
Error correction code memory can correct multiple bits of error. It can only correct single bit of error. So it's false. False.
Final answer.
False, yes. False. It can only correct single. So it's
Yeah.
false.
Correct. Correct. So I believe
Group
we
C,
are
Group C
beginning to
Group A to the
understand.
moon.
Yeah. Well, so the last one is
Group A to the moon.
So the last one is Group B. So Group B, your question: which memory model can support both 32-bit and 64-bit transfers of data?
I know Endicott wasn't very nice to us, but I still
Yeah,
feel
I did not take note of this.
He kept saying he didn't want our help.
When we're talking about the memory model,
It's Endicott's sweater.
Mm.
The store guy must be freezing.
I was
You
distracted.
know what? We should bring it to him. Maybe it'll make him feel a little better.
I can't.
It's the least.
are you the only one in your group?
I was distracted. I don't think so. Rosemary is in.
So where's
I don't think
Rosemary?
so. I was distracted. She's in the group. I was distracted. Yeah.
So it's only two of you.
Yes, I guess.
So how do you want to do it now?
Ah. Oh. I don't know this one. I'll not lie. I know I saw it, but I was distracted. So I will not lie that I was distracted then. Ah.
So
Oh.
so who is taking
Okay.
the bonus? Or you want to try?
I'll go
Bonus
to pass. So.
You want to pass or you want to try?
Let me try, but I'm not sure.
Okay.
Ah.
Your time is gone.
I'll go for dim memory.
This is long overdue.
Fine. Final answer.
Yeah.
Final answer has been done. So who is taking the bonus?
C.
Who is taking the bonus?
C now, C.
Group C, Group C.
So Group C. Oh yeah, take the bonus now.
Sim.
Final answer.
No.
What is going on?
The last option D. Option D.
Is that D?
Yes.
You said is what? What's your final answer? You have to be sure.
Option Option D, option D, option D.
What's the question again? I can't see the question from here.
They said the question is, sorry, the question is which memory module can support both 32 and 64-bit transfer data? Supports the two.
I can't see the question from here, Mr. Shabalala.
I beg of
Which memory? Hello? Sorry, my network had to. Can you hear me clearly now? Let me bring back the question.
Can you?
Yes, yes.
So do you have your answer now?
Sir?
Sorry, we were discussing before the network started messing up again. Which memory module can support both 32-bit and 64-bit transfers of data?
Sodium.
It says sodium. Yeah, the guy is correct.
You said it's what?
Sodium, sir.
Correct. All right, I really need us to, we have to revise this thing back. Yeah, it's not like it's something that gives serious issue when it comes to becoming or being an IT essential or tech support, but it's just a knowledge you just need to just know. You just have it, you know, you need to know the difference, okay? And like I explained earlier, from the, if you go through the sodium explanation, you will see it there. So the reason why we actually always do these classes is just to see the understanding, which means you still have to go back and do some, you know, reading and all that, so you can understand better, okay? So if you have any question, please, you can ask. Like I said, you can DM me, you can send me voice notes, I will explain. So by the grace of God, we should be looking, you know, into physical practicals this January, and I will announce the dates. Now, the way we do the practical is, if we're going to do it on a Saturday, it's going to be different time for different groups, you know, and that's why I had to group everybody, because we can't have a crowd. I want everybody to understand the practicals. So we can't have so much people trying to, you know, so we're going to do it timely. For example, if we're having a Saturday, some batch will come like in the morning, some will come by noon, some will come like in the afternoon. So we have a good time to really understand the practical of, but I want us to get to a point when we have the practical, okay? So you can see how the computer is assembled. You can assemble it yourself. You can check the memory, you can install, you can dismantle, because two ways. You must be able to dismantle a system, and you must be able to assemble them back. Once you're able to do that and you understand every functions and every troubleshooting,